Hey guys, my name is Ms. Lopez, and today we're going to be covering TEKS 8.5A, Solve Linear Equations in One Variable, including the application of the distributive property and with variables on both sides. In case you were wondering where I got these fancy algebra tiles from, here's the direct link to mathspot.com. Or you can simply type into Google online algebra tiles, and for me it's the first one that pops up, but it's the one under the mathbots.com that says algebra tiles. Or you can go the more physical route. These are probably the ones that you have in your classroom. Now I know everybody doesn't have these in their classroom, so if you're looking for a more budget-friendly option, these are printable algebra tiles. You can cut them out, laminate them for more long-term use. If you go into Google and you type in printable algebra tiles, if you scroll down, it's about the 7th one down. It's called Consume Math Worksheets. If you click the link, it'll open up a PDF and you can print this off and make copies. The first thing I recommend doing with your students when you're doing anything with algebra tiles is taking a minute to remind your students about the visual differences between the constant and the variable. So here you can start talking about the physical attributes of the tile. So for instance, in this example, the longer green tile represents 1x and the smaller yellow tile represents 1 unit. Now also, when you flip the tiles over, they are both red. This represents the negative or opposite of that specific tile, so negative x or negative 1. Then you can also remind them what a zero pair is. So when you combine a positive and a negative tile of the same size, they create a zero pair and are eliminated. In addition to algebra tiles, students will need an algebra tiles mat for solving equations. Now on the screen you can see I already have the T-chart drawn. You can add this on your screen by clicking the access button right here in the middle to the right. For the students, you can provide a printed copy of the mat, or you can have them just draw it on a piece of paper, a little T-chart. You can also take the printed copies and put them inside of a clear protector or laminate them so they can be reused. The students love to use Expo markers, so it'll be a good way to get them using the Expo marker. They can also use the Expo marker to write on the desk and draw the T-chart that way, or whiteboards, of course. But pencil and paper, simplest way to go if you don't have any of those other options. The first example that we're going to look at today is the 2x plus 4 equals 12. Now, this equation doesn't include the application of the distributive property, and it also doesn't have variables on both sides, but it does access prior knowledge. So this would be helpful to go over first using the algebra tiles so they can access that prior knowledge, practice using the algebra tiles, build some confidence. The first thing you want to have your students do is make sure they're writing their equation at the top of their mat. So you can see mine's right here at the top. Also remind them that this line going down the middle is going through the equal sign. So this represents the left and the right side of the equation. Next, I'm going to lay out my algebra tiles. Now, if you're using the digital ones here, you can drag them out right here from the left. So I got 2 of the green positive x tiles and then 4 of the smaller yellow unit tiles. And then on the right, I'm going to add my 12 yellow positive unit tiles. You can use these arrows up here at the top to just duplicate any algebra tile. This is easier when you have an algebra tile that's larger than 4. So instead of having to drag out 12 individual unit tiles, you can just duplicate it 12 times. Save some time. When your students are laying out each term, you want to make sure that they're putting them on the correct side of the equal sign. So here you'll see sometimes I like to cover up one side, lay it out, and then cover up the other side of the equal sign and lay that out as well, so students do not get confused and start laying everything on the same side. So now that everything is laid out, you can begin to solve your equation. Your students may probably start trying to move these 4 unit tiles on the left to combine with the right 12 tiles. So this is a good time to remind them that we're not just moving algebra tiles on the mat from one side to the other. we're creating 0 pairs so that we can eliminate them to isolate the variable. Also, while going through the steps, I'm going to write right here underneath what's happening algebraically as I move the algebra tiles. This will really help your students bring that connection in of the concrete with the abstract representation. So immediately I'm going to try to eliminate these 4 positive unit tiles on the left of the equation because my x's are already here on the left side. Now, remember, our equation must remain balanced. So if I add 4 negative unit tiles to the left to create 4 0 pairs, I have to also add 4 negative unit tiles to the right. Now, algebraically, this is why we would see that -4 subtracting 4 from the left side and then also subtracting 4 from the right side. So now I can simplify. On the left, the 4 positive unit tiles and the 4 negative unit tiles equal 0, and they're eliminated. On the right, we can also combine the like terms, so we're also going to eliminate any 0 pairs that formed on this side. So the 12 unit tiles and the 4 negative unit tiles create 4 0 pairs, and we can eliminate them, and we're only left with the 8 positive unit tiles on the right. Now, algebraically, that's why the 12 minus 4 equals 8. This step of combining like terms with the algebra tiles helps clear up the misconception of grouping or combining like terms that are not alike, because with the algebra tiles, they can visually see the difference between the x tile and the unit tiles. This now reads as 2x equals 8. This is not my final answer because I want to isolate the value and know the value of just one single x, not 2 x's. So from here we can separate these 2 x tiles into 2 separate groups of 1x. And I can do the same thing on the right side by dividing up these remaining unit tiles on the right and give an even amount to each individual x tile. During this time, you can mention the definition of division to your students and relate that to solving algebraically. So to divide is to create equal groups of. So if I'm dividing these 8 unit tiles into 2 groups, each group will have 4 tiles in it. Here you can bring in the next step for solving algebraically, which is dividing by 2. That is why our divisor here is 2, because we're breaking it into 2 equal groups. Then you must remain balanced. So if you're going to divide on the left, you have to divide on the right as well. The 8 divided by 2 is 4. So when we split up our unit tiles evenly, we get 4 tiles in each group, which is giving us our final solution of x equals 4. The next example we're going to look at is 3x plus 2 equals x minus 6. So I'm going to start by modeling this. Again, you can cover up the right side and model the left, which is the 3x positive green algebra tiles, and then the 2 yellow smaller 1 unit tiles. Then cover up the left and model the right side, which is the 1x here, positive, and then 6 red, smaller 1 unit tiles for -6. So first I want to isolate the variable. So one way you can solve this problem is starting by eliminating the 1x on the right side. To do this, I'm going to add my opposite tile, which is going to be a -1x here on the right to create a 0 pair and eliminate the 1x. And since this equation must remain balanced, I have to do the same thing on the left. So I'm going to add my -1x tile here. Then I'm going to combine my like terms. On the right, I have 1 0 pair that formed, and on the left, I also have 1 0 pair that formed. So I'm going to eliminate those. And now I'm left with 2x plus 2 equals -6. And don't forget to add what happened algebraically up there at the top. Right. So next I want to eliminate the 2 here on the left. You want to avoid saying the phrase get rid of and instead say eliminate, because we do not just magically get rid of anything. We eliminate from each side. So the 2 is currently positive. I'm going to add 2 negative unit tiles here on the left to create 0 pairs. And then also don't forget to do the same thing on the right, so that the equation remains balanced. So I'm going to combine my like terms. On the left, I create 2 0 pairs, so those will both be eliminated. And on the right, I'm going to combine my -2 with my -6 for a total of -8 unit tiles. And then also add up there at the top what happened algebraically. We added a -6 plus a -2, so we got a total of -8 now. The last step here is going to be finding the value of just one x, because right now I only know the value of two x's. So I'm going to divide these two x's into two separate groups of 1x, and then since I have two equal groups on the left, I'm going to divide my unit tiles into the two separate groups. I recommend having the students add the unit tiles to each group one at a time until they run out of tiles. So here you can see that the value of 1x is -4. You can go ahead and finish out the algebraic part at the top. This last example has the distributive property. I know that this is the distributive property because right here I can see that there are parentheses with a term directly in front. Since there's a lot going on in this equation, I definitely would use the strategy of covering up one side, laying it out, and then covering up the opposite side and laying that out as well, so that students don't make any mistakes of putting things on the wrong side. So the part right here reads 3 groups of 2x minus 1, which means we have to model 2x minus 1 3 times. I really recommend having your students lay out this first and lay it out in groups so they can visually see the groups of 2x minus 1 like this. This will help clear up the misconception and the mistake that happens when students forget to distribute the number in front of the parentheses to all the terms inside of the parentheses. I would also show them right here algebraically what's happening. So here you can see that 3 times 2x equals 6x, and 3 times -1 equals -3, because we distribute to all the terms, not just the first one. That is why after we combine like terms right here, we get a total of 6 x's and -3 unit tiles. So 3 negatives, not just 6x minus 1. Then we have these 5 positive unit tiles here also on the left side. Now I'm going to go ahead and switch to the other side. On the right, we have 4 positive x's and 14 positive unit tiles. After they have this fully modeled, I would have them combine the like terms by grouping your x tiles together and then grouping the constant tiles together. I'm going to do this one side at a time so that there's no confusion when combining things on opposite sides. So here you want to reiterate that we can combine these terms because they visually look alike. Remind them that since we're still on the same side of the equation, we don't need 0 pairs to move things around. So here I would definitely use the strategy of covering up one side, check for like terms, and then cover up the opposite side to check for like terms, just so we can avoid the mistake of combining things on opposite sides of the equation. So starting with the left side, I can see I have some like terms here. I combine these 3 negative unit tiles with the 5 positive unit tiles, and then remove any 0 pairs that form. And then I'll see here I'm just left with 2 positive unit tiles. Algebraically, you will show them that when we combine like terms, -3 plus 5 equals +2. And then on the right side, there's no like terms to combine. So after combining like terms and eliminating any 0 pairs that form, I'm left with 6x plus 2 equals 4x plus 14. So now just proceed to solve using the strategies we learned in the previous examples. I want to eliminate the 4x here on the right side. So I'm going to add 4 negative x tiles, and whatever I do to the right, I must do to the left so that the equation remains balanced. I'm going to look for any 0 pairs to eliminate and remove them. So now I'm left with 2x plus 2 equals 14. Next, I want to eliminate these 2 positive unit tiles on the left. So I'm going to add 2 negatives to the left, and then I need to remain balanced. So I'm going to add 2 negatives to the right and eliminate any 0 pairs I form. Next, I want to create my equal groups. Since I have 2 x's, I'm going to separate these into 2 equal groups of 1x so I can find the value of only 1x. I'll take my 12 unit tiles and distribute them equally until I run out. And you can see here my final solution is x equals 6.